evening. This is Anil Prasad Surampudi from Hyderabad, and I'm the computer science, an MBA, and MSc mathematics. I'm gonna take this computer architecture and organization for you guys who are the aspirants of GATE 2021. Okay. Now, as we are into fourth week, I guess, we've been through a few important lectures of the CPU. In fact, when we look back, we have been designing the CPU for a while, right? So we started with the CPU design. In the CPU design, we already designed the register set. Now, in fact, we've been designing the stack. Okay, let me give you a recap of a stack, after which let me explain you people how to solve the questions on stack. I will take one example GATE question which was given in the recent GATE years, and then I'm gonna go ahead with the rest of the lectures, such as you know instruction formats with respect to the number of operands. So today's topic is stack and instruction formats with respect to the number of operands. Stay focused right now. Okay. Kirti, good evening. Sheetal, good evening. Yeah. Say hi. I mean, I've been seeing you guys, around 5 guys are here. Just wave your hand here so that I would be able to understand how many of you guys are actually listening. Okay, fine. There is Kirti and there is Sheetal. Fine. Um, yeah, Sheetal. Sheetal Shahu, I did not understand your question. Yeah. Sri Pravallika, good evening. And Kirti, hi. And Sheetal, I did not understand your question. Kya? I don't know what you're asking for, but fine. Yeah, listen. We are into the fourth week right now. Already, I covered quite a few doubt sessions, which covered quite a bit of a CPU. Okay, we've been discussing about the CPU. Okay, in CPU, we started with the register set. Just stay focused. I guess you people are here for the first time, aren't you? You people here for the first time. Good. Okay. Let me give you a small recap of what happened so far, so that will be better for you guys, which makes you come out of your all the confusions and the doubts. Let me give you. I've been explaining in English only, Madam Kirti. Yeah, Kirti, I've been explaining only in English. I don't use Hindi or any other language. Okay, I hope you understand this. Okay, now let me give you an overview of what has been taught so far. Okay, in the computer architecture, we need to think from the point of view of a designer. We are not the end users. We are neither a programmer nor an end user. Okay, we are not playing games with the computer system. We are not using word processor in the computer system. Rather, we are not developing a Java program or C program. Here we are the core system designers, right? So what we'll have to do is we need to understand the total design logic of a computer system, CPU. Okay, most of you guys, let me tell you something. Most of you guys, 99% of you guys will really think that this is one of the difficult topics ever in your curriculum, right? Am I right, Kirti? Am I right, Sheetal? Am I right, Pravalika? You people might be thinking that this is one of the difficult topic. Am I right or not? But let me tell you, when you get into the details, actually it will be one of the most easiest topics ever. Let me conclude this. You might feel that, okay, being a lecturer, you might say that, but we don't feel that way. let me tell you, that is, once after you've been with me, you travel with me for this gate 2021, I'll make you feel that the computer architecture is one of the easiest topics ever. The only thing is, nothing is expected from you except listening to my lectures. That's it. Okay. Now, okay, so far what I told you is we need to think from the point of view of a designer. Okay, here, being a designer, what we need to design. There are a few things that are needed to be understood before we design a computer system. Okay, you know that there is a CPU, right? In the computer system, there is a CPU, which is considered to be the heart of the computer system. Without CPU, program execution is not possible. Okay, I do have a CPU. Okay, on the same motherboard, I do also have something called main memory. Pardon my drawing skills. Okay, think that this is memory. Okay, now being a designer, first of all, you need to understand about CPU and the main memory, how these two things are designed. Because on the motherboard, we do have only two elements. One is CPU and one more is memory. That's it. Okay. So when it comes to the CPU, CPU is a core part of the computer system in which the programs gets executed. Right? CPU is the core part in which the programs will get executed. It executes the programs. It's a program execution unit, CPU. Okay, so what is this memory? This memory is nothing but the main memory, what we already knew in our curriculum. We've been, hearing this term, this main memory, for a while right now. That is, memory is an integral part to the CPU, where the CPU executes the program and the memory stores the program. Okay, so this is the relationship between CPU and the main memory. The memory meaning, here I am referring to only main memory. Okay, I am not talking about the secondary memory or auxiliary memory here. Okay, the main memory will be storing the programs, and the programs which are available in the main memory will be executed by the CPU. This is the thing always happens. Okay, for a CPU, everything is nothing but a program. Either you watch a movie or listen to a song or execute a Java program, or you move a mouse at least from one position to another position. Anything is just nothing but a program for a CPU. If you want to get the desired results, a program has to be executed. For an example, you want to watch a movie. What will eventually happen within the CPU? CPU is going to execute the corresponding program with respect to the movie that you're watching, belongs to the movie that you're watching. So CPU is essentially and eventually a program execution unit. And the memory is a unit in which the programs are residing. Okay, so this is the basic idea that you need to have before we design the CPU. Okay, for the past 3 weeks, I've been explaining you guys about the design of the CPU. Okay, so again, what to be designed within a CPU? First of all, if you want to design a computer system, you need to start the design of the CPU. You need to start with the design of the CPU. Okay, so when you consider designing the CPU, first of all, you need to understand what are the entities that are present within a CPU, so that we can go ahead in designing with those elements. Okay, CPU will have 3 elements all the time, 3 entities rather. The first important entity for a CPU is a register set. Okay. Second thing is something called a control unit. And the third thing, which is something called an ALU. Okay. Initially, you need to design these three things. After you design all these three things, then your CPU is ready for executing the programs. Okay. So this is what all about something called instruction set architecture, ISA. Okay, which is a topic of your gate. This is called instruction set architecture. Sir, what is instruction set architecture? Instruction set architecture is just nothing but designing the register set, control unit and ALU, which are considered to be the integral part of the CPU. After we design them, then our CPU is ready. Okay, then we are going to completely understand what is this instruction set architecture. Okay, so that's it. I got a guy who is having no name, gaming incredible. Hi, anyhow, hi. Just better always represent yourself with your name so that it will be easy for me to communicate with you people, so that we can have a better interactive session. I'll ask the question, you ask the question. For anything, it is always better you represent yourself in some addressable name. Okay, that's it. So now for the past 3 weeks we've been designing the register set. Okay, so here when you design the register set, you might have a question, sir, what is this register set, and what is the purpose of having a register set within the CPU? Okay, you know that, first of all, my question for you, all of you guys, is, do you have any idea what is a register? Tell me, Sheetal, what is a register? Am I audible for all the guys? I'm waiting. Yeah, fine. A register set is going to store one word within the CPU. Okay. In fact, a register is a collection of flip-flops. Okay. So that is temporary memory used for operation. Very good. Giving temporary memory used for operation. And Kirti Harshavardhan. It is a log for the work to be done. Kirti Adil. Fine, fine. Very good. Whatever. So you got a basic idea what is the register set all about. So I don't need to get into the how to design the get into the details of how to design the register even. The register is simply a collection of flip-flops, right? What is a flip-flop? Flip-flop is going to store a 0 or a 1. There are many flip-flops, many kinds of flip-flops. D flip-flop, T flip-flop, RS flip-flop or JK flip-flop. No matter what kind of a flip-flop it is, when you collect a few flip-flops, it is going to give you a register which is going to eventually store a few digits in tandem. Okay, so a register set. So we are designing such register set. Why do we require a register set? Let me explain you here. Okay, as most of the guys are very new, I will take some time to give you the basic idea. How does it work actually? Okay, now what is memory? In memory we do have programs, right? In memory we do have programs. One basic fundamental rule for executing any program, try to understand. This is the thumb rule that you need to digest before you enter into the design of the computer architecture. If you want to execute a program, first of all make sure that the program is stored in the memory. Okay, if you can't store the program in the memory, there is no way you can execute it. Okay, the program is stored in all the programs. Whatever the programs that you have, when you want to execute them, those programs must be loaded within the main memory. Okay, so essentially main memory is going to store the programs. Then what is the purpose of the CPU? The CPU is eventually going to execute the programs, right? Yeah. When it comes to a program, what's a program? A program is a set of instructions. Program is a set of instructions. That is instruction 1, instruction 2, instruction 3, instruction 4, instruction 5, whatever. All these instructions are available in the main memory. When a program is executing, the CPU is going to fetch the instructions one by one and executes them. That is what the job of the CPU all the time. CPU has no other job than executing the instructions one by one. As I already told you, everything what you are doing within the computer system is just nothing but a program execution. So for this, we need to have a memory which stores the programs, and we need to have a CPU which executes the program. The job of the CPU, try to understand, carefully understand. When you are asked to define the CPU, rather, explain what is the job of the CPU, you got to tell me only one answer. That is, CPU always busy in executing the instruction only. Okay, because the CPU is duty is confined to execution of an instruction every time. If the first instruction is executed, then it gets the next instruction. When that is executed, then it gets the third instruction. Then it gets the fourth instruction. So, CPU will always be busy in executing one instruction. Other than the current instruction that is being executed, CPU does know nothing about any other thing. When you ask CPU, what is the program? CPU tells you, I don't know what is the program. When you ask CPU, what is the software? It is going to tell you, I don't know what is the software. When you ask the CPU about anything else, it is not going to answer you except the question, what is an instruction? Because CPU knew only about the current instruction which is getting executed. Right? Did I make it myself clear? That is, now the relationship between CPU and the main memory is going to load the programs that are being executed, and the CPU is going to execute one instruction at a time for the currently executed program. Did I make it myself clear? Good. So, that is the job of the CPU. CPU always be busy in executing current instruction. So, if you want to execute an instruction, that instruction which is available in the main memory should be transported to the CPU, right? If the CPU has to execute an instruction, that instruction must be transported to the CPU and should be made available within the CPU, right? Good. So, for this reason, I need to have a register set. Got me? That is it. So, this register set will give you a provision to store the currently executing instruction. Okay? Register set. Why? I mean, when you are asked a question, why? What is the reason in the world to have a register set in the CPU? Only one answer is, only one answer, which makes more sense for this is, the register set is going to store the current instruction and the associated data which is being executed by the CPU concurrently right now. Okay, for this reason, I do have a register set. Okay, so we've been discussing the organization of the register set. Okay, that is, first we need to start the design of the register set. Okay, what is register set again? A register set is going to store the current instruction and the associated data. For this reason, we need to design the register set, and that should be made available within the CPU. Okay, so now the question is how to design the register set. Got me? The question is how to design the register set. Answer is, you have three choices. If you want to design the register set, you have three choices. First one is single accumulator organization. Second one is general register organization. Third one is stack organization. Is the screen properly visible? Is the screen properly visible? I want the answer so that I will go ahead. Okay, in the register set, there are three ways to design your register set. The first one is single accumulator. Second one is general register, and the third one is stack organization. Okay, designing this register set is not a rocket science. Is very easy process. How to design this register set and understanding these registers is a very easy thing. Don't worry, I'm going to make it very simple. First of all, tell me if it is audible. Yeah, I think it is audible and visible, right? Very good, very good. Now, I will go ahead with the stack organization. Okay, I will start with the stack organization because at this point of period, last week I started with a stack. Okay, I will anyhow give you a recap of single accumulator organization and general register organization maybe in the upcoming weeks. Right now, I've been explaining the stack organization. Okay, so I will give you an overview of a stack. Did I make it myself clear? Now, in this class, we are going to see how a stack is going to be designed. Okay, Kirti, Pravalika, is it fine? And Harshavardhan, gaming incredible. Sheetal, yeah, on dances. We are now going to witness how a stack is going to be designed within a CPU. Okay, good. Fine. Now, what is a stack? Yeah, tell me, Harshavardhan, what is a stack? I want some answers before I start designing the stack. You people are familiar with the stack, aren't you? You people heard about this term stack in many of your I think topics. Many of the topics in many of the computer science topics, you would have heard about stack, right? What is stack? Lokesh Parab, and very good, very good. You are here. I've been searching for you because you are the only guy who've been consistent. I mean, you've been for the last 3 weeks traveling with me. Fine, good. Tell me, all of you guys, I want an answer. What is a stack? What do you know about a stack? Array, first in first out. It's not first in first out operation. Lokesh Parab. It's not a first in first out operation. Last in first out. Very good. Pravalika, you're right. It's a LIFO data structure. First of all, you need to tell me that whenever you are asked a question, what is a stack? Stack is just nothing but a data structure, right? Stack is nothing but a data structure. Ganesh Nomula, stack is not a temporary memory. Okay, stack, I'll let you know why your answer I don't accept in a short while. There are several things that are needed to be discussed within the stack. Okay, primitive data structure where it is the collection of elements. Very good. Now, fine. When you heard about a stack, rather you're trying to have an idea about a stack, you might have heard about many things. That is, stack is a data structure, and stack is going to have a collection of elements. Stack is going to give you the last element to be retrieved first, and so many things. Right? Fine. Okay, one and a data structure. Sai Pravalika. Good, good. Now, good for that. Everybody is participating. Now, listen to me carefully. In addition to what you have already learned, I am going to show you a different dimension of a stack. Okay, I am going to show you a different dimension of a stack. It is needed to be understood by you guys because you people are the programmers. Tomorrow, once after you finish 4th year, you're going to look at yourself a developer, right? You're going to see yourself as a developer in one of the software firms. Being a programmer, first of all, you need to be thankful for the guy who designed this stack. Okay, if there is no stack, it it would be very difficult for executing the programs. If you want to execute a program without a stack designed in the system, you should turn the world upside down. It is that difficult. Program execution paradigm would be completely difficult without a stack. So, being programmers, we should be thankful for the designer of the stack. Why? How? What? I'm going to tell you in a short while. Okay. So, first we understand how to design the stack. Okay. Now, when you want to design the stack, you need to understand two important things. There are two kinds of stacks. Being from the designer's perspective, there are two kinds of stacks. One is a register stack, and second one is memory stack. For those people, who are with me for the past 3 weeks, it would be a kind of a repetition, but spare me because I do have many people today, the freshers, rather, the new joiners. I need to give a recap because I'm in the middle of the stack. I can't continue from where I stopped in the previous week, because if I do that, these people won't be able to understand anything that I explain. So spare me, Lokesh Parab, because for you it's a repetition, but anyhow you just listen to me once again. It will give you a complete recap so that you will be in a better position to answer any question on the stack. Okay, so there is a register stack and there is a memory stack. What is the difference between register stack and a memory stack? Simple. The register stack is designed only for the CPU and will be available within the CPU. Memory stack will be implemented in main memory, is designed and put it in the main memory. Okay. So what is this difference? I'll tell you what is the difference. Okay. I'll tell you what is the difference. What is main memory? What is main memory? As I already told you, main memory is a collection of the programs. What is the purpose of the memory? Main memory? Purpose of the main memory is to store all the programs that are being executed. Because when we do not store a program within the main memory, that program can never be executed. Okay, only those programs that are brought into the main memory will be executed by the CPU. Okay, stay focused here. Okay, this is program 1, program 2 and program N. Okay, here this is the CPU. Now there is a stack within the CPU. Understand that, think that at least this is a register stack. This is a register stack. Okay, a register stack will be available within the CPU. Okay, but when it comes to the memory stack, for every program there will be a dedicated stack. You might have heard about this, that every program or a process requires to have its own stack in the memory. So for every program there will be a dedicated exclusive memory stack. So how many memory stacks will be there? Will be equal to the number of programs that are loaded into the main memory. If my program, rather, if the number of programs that are available in the main memory are equal to 100, there will be 100 memory stacks. Okay, if you load 1000 programs into the main memory, there will be 1000 memory stacks, because each and every program requires its own and dedicated stack. Okay, stay focused. Now, why every program requires a stack? I'll explain you that. Before we design, some basic things that are needed to be understood, I'll explain you initially. Okay, what will be stored into the stack? Try to understand. Think yourself as a programmer. When you write a program, you're going to declare local variables, right? Yes or no? What's the local variable? Tell me. Kirti, Ganesh, or Pravalika. Tell me what's the local variable? What is the local variable? Local variable is confined to a limited section of a program, right? Yes or no? A local variable is confined to a specific section of a program. Now, when you write a program, obviously the program contains many of the local variables, and when you try to load the program into the main memory, all the local variables will get stored into the stack. Okay, if you want to store a local variable, you need to have a stack. Okay, so always understand that all the local variables, when a program is getting loaded into the main memory, will get stored into the memory stack. So every program requires its own stack. Okay, in addition to this local variable, stack will also hold something called return addresses. Okay, don't ask me what is the return address right now. It will be, it will take some time to understand what is the return address. Return address can also be called as a program counter value. Okay, stack also stores the program counter value, and stacks also stores sometimes flag register. Okay, every program has its own local variables and program counter value and a flag value. Okay, so when a program is getting loaded, all these will get directly loaded into the stack. So for that purpose, every program requires its own stack. Now understand that this currently, I want to execute program 2. CPU decides to execute program 2. You know that the program 2 has its own stack elements. What are available in the program 2 stack? Program 2's local variables and the return addresses and the flag registers, right? So when the program 2 is getting executed, all the stack values of the program 2 will get transferred to the register stack, because when you want to execute program 2, all the values must be transferred to the local storage provisions of the CPU. The local storage provisions of the CPU are two. One is registers and one more is stack. So all the stack values of the program 2 will get transferred to the register stack whenever it is getting executed. Did I make it myself clear? This is the reason why I do have two different kinds of stacks. One is within the CPU. The CPU stack is going to hold the stack values of the concurrently executing program, and the memory stack is going to there will be several memory stacks. Each memory stack will be dedicated to a specific program in which that particular program's local variables, return addresses and flag register value will get stored. Okay, so this is the difference between register stack and a memory stack. Let us design a register stack. Stay focused. I am going to explain how to design a register stack. I am designing right now a register stack. Okay. My register stack is of 8 elements. Okay. What is the register stack? Register stack will be made available within the CPU. 1, 2, 3, 4, 5, 6 and 7 and 8. I am going to design a register stack. There are 8 elements. So the addresses of these elements will be 000, 001, 010, 011, 100, 101, 110, 111. Alright. Did I make it myself clear? I am designing an 8 element register stack. Okay, as it is 8 element, there will be 3 digits in the address of each location, because 2 power 3 is equal to 8. 0, 0, 0 being the first location's address, 111 and 111 will be the final address of the final location. Okay, now before we get into this stack, first of all understand the elements that are associated to this stack. There is something called a stack pointer. May I ask you what is a stack pointer? May I ask you what is a stack pointer? While I am listing out the remaining elements that are related to the stack, please answer me the question, what is a stack pointer? Then there is something called a data register. Okay, and there will be 2 flags. One is full and one more is empty, full and empty. And there are 2 operations that are possible on the stack. One is push and one more is pop. Okay, empty is the way it spells is empty, but the flag mnemonic is empty. It will show you the status of the flag when it is empty. Okay, Lokesh Parab, very good. It is going to show the top of the stack. Stack pointer is going to show the top of the stack. Yes or no? Kirti, answer me. What is a stack pointer? Pravalika, answer me. What is a stack pointer? What stack pointer shows? What stack pointer exactly shows? What is just nothing but a stack pointer? Yeah, fine. Stack pointer is a pointer which shows the address of the topmost element of the stack. Did I make it myself clear? Is it clear? The stack pointer is a pointer to the top of the stack. Okay, it shows the topmost element. Pointer to TOS. I don't need to expand TOS because TOS is just nothing but top of the stack. Okay, and then data register. What is it, Kirti? It's a small register that stores the address of the last. No, I'll tell you. Stay focused. Yeah, I'll tell you. It's a pointer to the top of the stack. I'll tell you what is a pointer to the top of the stack. Data register is a data source for the stack. Data source for the stack. And full is a flag which shows the status of the flag. When the stack is completely full will be equal to 1. When the stack is completely empty, then empty will be equal to 1. These full and empty are 1-bit registers. When these are equal to 1, and the corresponding status will be represented in the stack. For an example, when full is equal to 1, stack is completely full. Or when empty is equal to 1, stack is completely empty. Okay, what is push and pop? Push is just nothing but an operation that is going to be performed on a stack, right? When you perform push operation, one element will be pushed into the stack. When you perform pop operation, one element will be popped out of the stack. Okay, now let us stay focused how this stack is going to be designed. Now, initially there is nothing in the stack, right? Initially there is nothing in the stack. So stack pointer is going to show 000. Stay focused. When you want to perform a push operation, what will happen? Let me explain you completely. Let us say that this is the data register. Let us say that this is the data register. This data register is a data supplier to the stack. When you want to perform a push operation, the word of the data register will be pushed into the stack. Did I make it myself clear? I want to perform a push operation. For that, what is the source? You need to go to the data register. In the data register, there is a word. Get that word and push it into the stack. So this is what always happens whenever you perform a push operation. So when you perform a push operation, what will happen? Let me tell you. Okay, push operation will have following sub operations. Initially, stack pointer will get incremented. SP is equal to SP plus 1. When you perform a push operation, stack pointer get incremented. SP is equal to SP plus 1. Then the contents of the data register will get transferred to the memory of the stack pointer. Then data register contents will get pushed into memory of the stack pointer. Okay. Initially what happened? Stack pointer will be incremented and now stack pointer comes here. Did you get it? When stack pointer comes here, stack pointer value will be 001. This is the address of the topmost element of the stack, in which the element 1 will get pushed. This is going to happen all the time when you perform a push operation within the stack. Okay, did I make it myself clear, the initial operation? Yes or no? Every time when you perform the push operation, you need to remember two things. The first thing is stack pointer will get incremented. Okay, push operation, increment the stack pointer. After incrementing, in the memory of the stack pointer, the contents of the data register will be pushed. Did I make it myself clear, Kirti? Good. Yeah, element 1 has been pushed in here. Okay, so when you want to perform one more push operation, stack pointer will come here, element 2 will get pushed here. Here element 3. Okay, finally stack pointer comes here and element 7 will get pushed, right? Element 4, element 5, element 6, element 7. You might get a doubt that 000, the first element of the stack, is not used, because the rule of a push operation is incrementing the stack pointer. After incrementing, I'm just explaining. Stay focused here. First, what will happen? Initially, stack pointer will get incremented. Okay, so stack pointer will come here. Yes or no? Imagine that there is nothing. Stack is completely empty. There is no element 1, there is no element 2 or element 7. Stack is completely empty. Now, you want to perform a push operation. What will happen? Stack pointer is 000. Stack pointer will get incremented to 001. In this, element 1 will get pushed. Okay. For that, what is the source? The element is available in data register. If you want to perform a push operation, if you want to transfer the data into the stack, the data must be available within the data register. The contents of the data register should be transferred to memory of the stack pointer. What is memory of the stack pointer? I'll understand. I'll explain. You'll make you people understanding this. Stack pointer is 001, right? What is 001? 001 is an address. Yes or no? Under this address, element 1. So, memory of SP is stack pointer is 001. Under 001, element 1 will get pushed. SP is equal to 001. Okay. Memory of SP is this location. This is only address. This is the location with respect to this address. So, under this memory address, the data register contents will get stored. Did you understand this, Kirti? Or should I explain it one more time? Did I make it myself clear, Kirti? Pravalika, did you understand? I've been waiting. Good. Okay. So, finally stack pointer reaches here, 111, right? Now, do you understand that 000 is left alone? 000 is not filled with this. Already stack pointer reaches to the maximum value that it can, and stack actually losing the first element. Did you get this doubt? Yes or no? Lokesh, perhaps you know it already. So, once again, you just listen to me. It will give you another dimension. Pravalika, did you get my point? Already we reached to the top of the stack. In 111, element 7 has been placed. But still, there is slightly, something which is not right. Because this element hasn't been used yet, right? Yes or no? Very good. So, stay focused here. Can we use this element? Is there any way that we can use this element? Don't tell me no. Let me tell you. A designer's perspective. Forget about a stack. Anything what you design. Let us say that the Kirti is designing something. Let us say that the Kirti here is designing something, a hardware thing or a software thing or something she is designing. When she is designing something, she won't be happy if the designed entity is not utilized to its potential. As I already told you guys in my previous session, let us say we design a table. Rather, we design a sofa set in which 6 members can sit at any point of period at a time. Okay. Will the designer be happy if the sofa set is used by only 2 people all the time? No. Whatever the thing that is being designed should be utilized to its fullest extent. Okay. So, do not think that this element can never be used. This element can still be used. How? Let me tell you once again. That is, okay, already we started pushing these elements. Now we reach to stack pointer which is equal to 111. Still this 000 is left. But still we can perform one more push operation because initially what we are doing? We are incrementing the stack pointer, right? So, now what is the stack pointer? Stack pointer is equal to 111. When you perform a push operation, what will happen? SP is equal to SP plus 1. So, 111 plus 1 is equal to 000 only. Did I make it myself clear? Did you understand this? So, in 000, element 8 will get placed. Did you understand why 111 plus 1 is equal to 000 but not 1000? Kirti, did you understand why 111 plus 1 is equal to 000? Pravalika, did you understand why 111 plus 1 is equal to 000? Yes, because stack pointer is a 3-digit register, right? Only it can hold 3 digits. When you increment 111 plus 1 is equal to, actually in the arithmetic way it will be 1000. But there is no room for this carry. So that this carry will be discarded. So the stack pointer will just be left with only 3 digits which are equal to 000. Did I make it myself clear? So stack pointer will come back to 000 in which element 8 will get placed. I hope you got me. Okay, so this is what the design logic of a stack. When you pop, what will happen? Pop will involve in 2 operations. Again, that is first one is memory of SP. Spare me. Memory of the stack pointer will get transferred to data register and SP is equal to SP minus 1. Okay, so very good. It's a binary bit addition. So, what will happen? End carry will be discarded because there is no provision to accommodate this end carry. Fine. So, when you perform pop operation, what will happen? Initially, pop, the content will be popped out, then stack pointer will get decremented. Try to understand. In the push operation, initially stack pointer is getting updated, then push is being performed. But in pop, initially pop is being performed, then stack pointer is getting updated. This is the only difference between push and pop. Okay, once again, just digest what I said. In the push and the difference between push and pop operation, pop operation is in the push operation, stack pointer will get incremented first. That was the initial thing to do. After which, the regular push operation, the contents of the data register will get transferred to memory of the stack pointer. But in pop, what is happening? On the other hand, memory of the stack pointer is getting transferred to the data register, which is just nothing but a pop operation, after which stack pointer will get decremented. So obviously, when you perform a pop operation, what we'll get? Element 8 will get transferred to the data register. Then stack pointer will get decremented. 000 minus 1 is equal to 111. You know why? I don't need to explain. 000 minus 1 is equal to, in the borrow method, we are going to get 111 only. Okay, so any subsequent decrement will get you to back to the stack pointer, which is equal to 000. Again, two rules. Rule number one for status. Okay, there are two important status of the flag. Sorry, status of the stack. One is full. One more is empty. Okay, there are two status. When you can tell me that the stack is full, after push operation, if the stack pointer is equal to 000, rather 000 or 0, or if the stack pointer is equal to 0, then stack is full. You already knew this. Okay. Initially 000 is empty and stack pointer is going to show 000. Initially, when you try to push an element, when the stack is empty, it will get pushed here, pushed here. Finally, the final push operation will be made in 000. Okay. So, which means that when stack pointer reaches to 0 after performing a push operation, then it means that the stack is completely full. There is no stack overflow. Stack overflow is something different. I will explain you what is stack overflow. Stack overflow cannot be done in the register stack. Stack overflow can only be done in the memory stack. I did not go to memory stack. Here, keep it in your mind always that register stack, in the register stack, overflow can never happen because the register stack within the CPU. Okay, I will explain you what is stack overflow while I give you a detail about the memory stack. Okay, now when we get, rather when the stack pointer is equal to 000 after performing a push operation, then the stack is full. Okay, second point is when the stack can be empty. After performing a pop operation, if the stack pointer is equal to 000, that is equal to 0, then stack is empty. Did I make it myself clear? Anyhow, initially stack is empty. Once after you perform all the push operations, stack pointer will be 000, right? Initially stack pointer is equal to 000 when the stack is empty. After performing all the push operations, again you will come back to 000, right? Which means that when you reach 000, when the stack pointer reaches 000 after push operation, that means that stack is full. When the stack pointer reaches to a 000 after performing a pop operation, that means that stack is empty. These are the two important things that are understood, which are related to the stack. Did I make it myself clear about the stack? If you understand this, I am going to give you some important detail about the stack, which is really important to solve the gate questions. Did you understand these 2 points? Very good. So, before I explain you about a memory stack, let me tell you that the stack can be designed in two different logics. One is upward stack. Second one is upward and downward. There are two kinds of stacks. Being a designer, you can choose any of this design logic. Upward stack, what is the difference between upward stack and downward stack? Stay focused. I am giving you one important detail. We are about to understand one important, very important phenomena of how to design a stack. Okay. Now, in the upward stack, initially stack pointer points to 000. In the downward stack, stack pointer points to 111. Did I make it myself clear? Okay. So in the upward stack, stack pointer grows upwards. That is, during every push operation, stack pointer will get incremented. During every pop operation, stack pointer will get decremented. But when you chose downward stack design, stack pointer will initially show 111. Okay, which means that during a push operation, stack pointer will get decremented. During a pop operation, stack pointer will get incremented. Did I make it myself clear? Isn't it so simple? In the upward stack, push operation, spare me. It is not writing properly. Just a minute. Yeah, I will write it here. In the upward stack, for every push operation, SP is equal to SP plus 1. Okay, stack pointer will get incremented during a push operation, decremented during a pop operation. That is, I don't need to write it because it is understood. But when it comes to a downward stack, for a push operation, stack pointer will get decremented. You know why? Because initially it is showing 111. Yes or no? Did I make it myself clear? Did you understand this or not? Now, let me tell you something. Most of you people wouldn't know about this downward stack. Your teachers or lecturers told you about only an upward stack convention. You don't know that the stack pointer can also be decremented during a push operation, because when a designer wants to design a downward stack in his CPU, he will start the stack pointer with this element, that is the 111. Okay, so stack pointer will get decremented during a push operation and will get incremented during a pop operation. Did you understand, Kirti? So we're going to end up this session. We're going to completely understand about this upward stack and downward stack. Why the stack pointer is needed to be designed in such a way to be decremented, and thereby designing a stack by using the convention of the downward stack. We're going to completely understand in the next week when I explain you guys about a memory stack. Did I make it myself clear? Good. Okay, so that I will end this session up. So next week, exactly be here at 6 o'clock, because next week for the first 15 minutes, I'm going to give you the details of the memory stack, after which I'm going to explain you guys how to solve the questions on the stack in the gate. I'm going to take a few examples of the previous gate questions and give you a complete idea how to solve any question on the stack. Okay, so thank you so much. Meet you same day, same time next week.